Hello everyone and welcome back to Colorviz. We are back with summer assignment week 1. I'm sure you're sad to see the assignments back, and hopefully you're happy to see this back to hopefully help you with your assignments. So firstly, as usual, we'll go through the topics. This is just the topic list. Honestly, with the next week we're doing series. Series is just plugging formulas in. It's really easy. Same with volumes of revolution. If you don't like integration, then it can be quite annoying because you have to think. Sometimes you have to think about like cylinders and cones and like adding and subtracting them. But most of the time, it's just plugging it into the formula, and it'll give you a nice integral usually. The only hard part of the summer topics is the complex numbers and the Argand diagrams, which can be quite annoying, as you'll see on assignment 1B. But the only hard part is really when you get to loci in the Argand diagrams and finding areas in Argand diagrams, but it gets better as you go along. Honestly, it's one of my least favorite topics in further. But anyway, let's move on to the assignment as usual. Okay, we will start with 1A because that's the one I'm on right now. So yeah, it's good to be back. So firstly, a lot of these questions are quite similar. They're quite nice, like calculus questions and modeling. So dy dx, just dy dt over dx dt, simple stuff. Stationary points set to 0. Remember, you never need to worry about the denominator. So you just get cos dt equals 0, and you get these points. Remember, this is theta, so because it's parametric, so you have to substitute into x and y, and that's why these answers are 2 pi and 6 pi, and they're not in this range, but this is the range of theta and not x. Next question, we have a nice differential equation. You just rearrange it, do the integral, is pretty simple. Just remember that p0 is just this constant here. The initial is going to be this ln p, you e to the both sides, and then the e to the c goes to the front, and then that becomes a, which in this case is p0 because that's the initial. Next, value of k is assumed to be 3, where you just substitute 3 in, and we want the population to reach p0 again, and when the population reaches p0, that's when this e to the sine 3t here is 1, which is when sine 3t is 0. So obviously that's going to happen when t is 0, which is when p equals p0, and then the next time that happens is when t equals 3t equals pi, so therefore t equals pi over 3, and then you substitute, or then you have to multiply that by the I have to multiply because t is in hours. It's in days, sorry, and you multiply that by the number of minutes in a day. Okay, next question. I've gone a little bit out here. There's another differential equation. So there's a lot of partial fractions in this and these types of differential equations. So we're just going to separate the fractions, do the learns, do all this, and you get it. I think this next part is either wrong or I'm just really stupid. So you substitute the stuff in. I found a and 3k, and then I just said u equals 2e to the 3kt, just because I can't be able to write it out. So I just did that, multiplied by m minus 3 both sides, and then rearranged for rearranged for m, and then substituted back in. But somehow I got this denominator, so anyone has to let me know if they got a different answer. But I checked it with a bunch of stuff, and it looked like this was the better answer. And then just show that this last part is when t approaches infinity. Yeah, actually, because that does make a lot of sense, because you have, in this form that they give, the limit as t approaches infinity is 6, therefore 3 grams of the compound can be produced. So, but with the actual model you're supposed to get, which is the thing that I wrote down here, when you do the limit as t approaches infinity, you're going to get 3, which will, wait, what the? Yeah, you're gonna. Or I don't know if you think about this question very well. You're gonna get 6. So actually, maybe this is right, because what they did here is, so ignore why diff part C, sorry. But with this model, what you can do, you can multiply both sides. Or no, when you substitute t as infinity, the times with e in them will just go away. So the limit as t approaches infinity is just 3, or 6 over 2. And therefore 3 grams can never realistically be produced, because that's when t approaches infinity, which obviously can't happen. But yeah, someone's gonna have to let me know how I got this wrong. This thing, it says or otherwise, so I just didn't do substitutions because it's easier. This is just a learn, and then this is also just a learn, and then this one you just expand and then solve. you just expand, set it equal to the thing, and then solve for k. All right, here there's some other stuff. Oh, this is another one that I think that in the answers, they flip two of the answers around, because this is correct that a is 1, b is -1, but I think in the answer they did the other way around, because I was doing it with a being -1 and b is 1, but then it just gave me the wrong answer, so I'm just assuming this is correct. And then after this, you just do a substitution, dx equals 2t dt, which cancels with this thing on the denominator, and then you get the partial fractions thing that you did in the first part, and then you do partial fractions, integrate, and then substitute your limits in. Same thing here, you just do a, b, and c. You find their values, there too. To be fair, I did just being completely honest, I should look to the answer for this. I cannot be bothered to do division. But yeah, then you do the substitution, and then it gives you the exact thing, and you just substitute it in, do the integral, and then you get the answer. I think I moved a bit to the left here, yeah. Right, next we have this. You just substitute. This is a lot of the same thing. Here you just use identities for. You use the correct identities for cos 2x so that the ones cancel, and you just get tan squared x, which you can do a few identities on. You get this, and then you substitute it in. Same with this one, where you just do, say this is cos over sine squared, and then which is just cosec. This is a form you should recognize, cos over sine squared, because that just integrates to negative cosec. But obviously there's a 2 here, so it needs to be halved. Another partial fractions, relatively simple. Another integration of partial fractions, blah, blah, blah. Getting to the answer, nice. This is another question. You just do y dx dt, as I've shown a few times. I need to actually zoom out. Oh god, what have I done? I should probably zoom out a little bit, but I actually don't know how, because, right, it's fine. So, yeah, well, you just do your integral y dx dt. This is not the right page. You do your y dx dt. You expand this. The 6t cos t times 3 sec t. The sec and the cos cancel, and then here the sec sine is just tan, and then you expand, factorize the at now, and you get the right answer. I should definitely zoom out a little bit. 100%. That's probably better. That's better. Yeah. So, yeah. You then part B, you have to multiply by, so this point you get being 6. The x coordinate at this point you get being 6 times. Sorry. You get being 6 times pi over 3 times 6 times sine pi over 3, because you want we know this point P here is at t equals pi over 3, and because you can find that out from the earlier part, and then you substitute that in to find the x coordinate, and then it's just a rectangle, and then you subtract that from the integral, and then you find that out and find the answer. Next, this is really easy, just like domain range functions, blah blah blah. The range here is just substitute. This is just a simple substituting numbers in a question. The domain and range flip, which I'm sure you remember from the A level. All the stuff, same thing, just substitute stuff in. I mean, you have to differentiate, but I didn't even really show it because it's easy. Just some chain rule. Question 10, they decided to bring in something that everyone loves, what have I done? Did I just do... What have I done? I have done the... Oh, yeah, sorry, it's right here. So, you find the coefficient of x squared, do all these expansions. I'm not going to explain this. This is just easy. And then part I, you just set this equal to 7. You set the thing inside the bracket equal to 7, then solve. And then you can let x equal that thing to find the cube root of 7. Next. Another thing they wanted you to do, so this is just some like verifying stuff. So you implicitly differentiate, you get the answer. Okay, you substitute the y as root 2x plus 1, and then you do the normal differentiation with the chain rule, get the same answer. You should probably have plus or minus here, but it wasn't in the answers. This question sucks, it's just annoying. You differentiate, then you factorize, and then you differentiate again, and then you factorize, just a lot of product rule, and then you set it equal to 0, get x equals 1. Now this question is quite interesting. So obviously part A you just differentiate, and part B what you're supposed to do is just differentiate again and then substitute it back in. But I decided to not do that because this entire assignment's been pretty boring so far, so I decided to do something else. But you don't need to worry about that. Just all you have to do here is differentiate again and then substitute it into here, and it will equal 0. Next question, we have the series. All you have to do do the sum formula again. Number of positive terms in the series. Well, when un equals 0, that's when it goes from being positive to negative. So the number of times before that is the number of positive terms in the series. Then part B is just quite annoying because you have to like think about the number of terms, because there's actually 21 terms. And then obviously common difference 4. First term is just 52 because you look at the 10th term, sorry, 51, and then it equals that. This one, some simultaneous, this is like a common thing. Oh, it's not simultaneous, but just finding A equals that, sub it in, get R, and then substitute it into the formula. And this is what I was talking about. You just, this is just an S infinity subtracts to S5. But this part B is just some simultaneous equations. So you find the third term is 8. Sorry, the third term is 27. The sixth term is 8, and then you divide both equations together. I apologize for the noise in the background. And then you find A, blah blah blah. Okay, there's a lot of noise in the background. Jesus. And then the last question on this one, we have just a simple trig equation. I'll be doing a few more explanations on the complex number assignment because this is just standard stuff. You expand the sign to x. Get your answer, and then get your expansion, and then multiply by sign, factorize cos out. Remember, don't miss out on a solution. Okay, sure. And then you'll get cos theta equals 0, theta equals 90. You'll divide by that, rearrange, and you get your answers. Okay, I'll move on to this question in a minute. I just need to, I don't think I can mute this mic because you might be able to tell that I got a new mic if you compare this to my previous videos. But I think we'll just move on and you guys can just deal with that. So, actually, one sec. Okay, I don't think I'm going to be able to stop it, but it'll be fine. So this assignment 1B was kind of annoying if I'm being completely honest, because it's just a lot of random stuff. So question 1, boring. So you're just gonna, there's nothing special here. You're just expanding your brackets and you eventually get the answer. Question 2 is basically the same thing except you introduce some unknowns. I guess they're trying to give people a nice introduction, but this is anything but a nice introduction. Now, question 3 is actually an interesting one. You could do this a few different ways. You could say that, so I think what you're supposed to do is what I did on 3 part A, as you can see here. So what you see what I wrote before 3. Z squared, if you set z equal to x plus iy, which is what they say, you get this. So the real part of z squared, the real part of z squared is going to be x squared minus y squared, and then the imaginary part is going to be 2xy because of the expansion. So then for this one, for example, you can say that 0 equals x squared minus y squared, therefore x equals y, and that the imaginary part is minus 4, so 2xy equals minus 4. You set y as x because they equal each other, and then you get x and y, and then write it out like that. Next, now the other way you could do this is by using modulus and argument. So I wrote it in exponential form. You don't need to do this. So the modulus of this for b, the modulus is 9. The argument is pi over 2. Oh my god, this is actually insane. The modulus is 9. Argument is pi over 2. So if you square root it, the modulus will just square root itself, and the argument will divide by 2. You'll learn more about the modulus argument rule. You technically have done it in Arcane diagrams, but you learn more about it when you do exponential form next year. But then obviously you have your new thing. So you have the argument is tan y over x, and then the modulus is that, and you just rearrange a little bit and you'll get your answer. Same with this one. Get your modulus, divide the modulus by 2. Square root the modulus, divide your argument by 2. So this is y over x equals tan pi over 6, and then therefore root 3y equals x. Your argument equals that. X squared plus y squared equals your this is your modulus, sorry, because root x squared plus y squared equals 2. And then you do a little bit of rearranging. And then for this last one, I did the same thing you were supposed to do, where I set the real components equal to 5, the imaginary component equal to 1, and then do some simultaneous equations, solve your quadratic, and then you'll get the answer. I don't know why they were just like, oh, this is the easiest thing ever, and then they threw this at us. But anyway, now we're back to being easy. So this is called realizing the denominator, technically. And all you do is multiply by the conjugates. I'm not going to go through this. You just multiply. So for this one, you multiply by 1 minus 2i. And then your answer would reveal itself. All right, question 5. You're trying to find these complex numbers. So just isolate z. So here, just divide and then rationalize. Here, for b, z just equal. You kind of just tell that z equals 1. Because when you set z equal to 1, that happens. And then for part C, you can obviously just do normal stuff. You just rearrange a little bit, expand. You don't even have to expand. You just divide by 3 minus 4i and then add 1, and that's your answer. And then part D, you do the same thing. Just divide by 3 plus 5i and then add 5i, take away 2. All right, question 6. This is kind of like a little partial fractions type question, as in like you can... it's the same setup as when you're doing partial fractions, except instead of equating like the x squared terms in the x terms, you're equating the real terms in the imaginary terms, and then you solve simultaneously. Now, question 7 is actually an interesting one. I'd be interested to see how other people did it, because obviously with simultaneous equations, you want to either get into a point where you can set them equal to each other and cancel a variable, which I didn't think was very possible here, or you want to be able to subtract them from each other and cancel a variable, which is what I tried to do. So I tried to make it that for 7, I times some number equals 1 plus I. So I want to multiply this equation by some number to make the z in this equation 1 plus I. So you can subtract it, and I got that k is 1 minus I. So I multiplied this entire equation by 1 minus I, and then eventually it would become an equation where this is now 1 plus z on the left side, and you can subtract the two equations to get rid of the z's and solve for w, and then you can substitute them back in for z, obviously. Now I wrote down this little thing for question 8. So for when you have two roots, obviously they're going to be conjugates. So the other root here is going to be 2 minus 3i. But the main thing is that this is what it looks like when it's expanded on question 8. So obviously it's going to be, for this, it's going to be z squared minus 2 times whatever the real component is, plus x squared plus y squared. So if you just know the two roots, you can just substitute this formula in, which is what I did for all of these questions. You just use the formula and then you get the answer. Now here's the same thing. You just set z to x plus iy, set z starts at x minus iy, and then equate real and imaginary. Now for part B, what I did here was, what did I do? Oh, you just divided by I for the first equation and then subtracted them. That was a lot easier than the other one. Now question 10, same thing, just rearrange for z. Same for part B, rearrange, or if for part B, you just do the x plus iy thing from this question. And now we're out of complex numbers. So all this really was just stuff about the conjugates, so making the imaginary part the opposite sign, and then realizing your denominators and solving for z, which is all just comes from kind of the same thing. But anyway, let's move on to the other questions. dy dx, yeah, easy stuff. It's a bit annoying because you have to do all this annoying quotient rule. But yeah, next, substitute, easy stuff. Part B, you can just, so this is actually, a lot of people don't realize how to find points of intersection with parametrics. You just substitute the xt equation and the yt equation into here, and you can see where the two things intersect. Now, question 12, find the coordinates of r, so just set it equal to 0, or set the x1 equal to 0. No, sorry, set the y1 equal to 0, and then solve for t, and then substitute it into the x1. Part B, dy dx, like normal stuff, substitute, going to get your y minus y1 equals mx minus x1, and then you'll get your answer. And then find the coordinates of q. You do the same thing you did earlier, where you substitute the x and the y coordinates into this equation here. Substitute the x and yt equations into this equation and then solve. Now question 13, the crucial thing here was to separate this 3x plus y into the e to the 3x times 3 to the y, and then you can divide by e to the y and solve this differential equation. You had to do a little bit of parts here, which was fun. And then you just did it like that. And that's your answer. Now you do your boundary condition. And that's just going to give you C. Another differential equation. This is another easy one. Just divide and then do the lns. Implicit differentiation. I mean, I have nothing to really say. It's just the same thing. You've seen it before. And then finding the stationary points, well, you know the derivative is 0, so 3y equals 8x, therefore y equals 8 over 3x, and then you can substitute that into the main equation, which would just give you a nice, like, ax squared equals b type equation, and you just get this. This is another interesting one, actually. You can just do it like differentiating both sides, but you can actually just use the original equation. This is y squared equals x to the x, and you can differentiate both sides. And obviously the derivative of x to the x, you have to use Lund's for, but if you just remember the derivative of x to the x, then you can just do this without having to do all this implicit stuff. So you still have to do implicit, but it's a lot easier. So you can just do that and then divide by 2y and you'll get the answer, and then obviously substitute. And then, yeah, that's going to give you your answer. Last question, flashback from assignment 1A, I think, with the substitution questions, and this is just a nice and easy one. You just have to substitute, it instantly gives you a nice answer. Part B, substitute, you're going to get the dx equals like cos theta d theta, and that's going to cancel with the half power from here, and then one of the powers will still be there, so it will give you sec squared theta, and then that just integrates to tan. Trig sub is just something that you have to get used to. I mean, you probably are used to already since you've done the A level, but yeah. Right, hope you've enjoyed that video, or hope it's helpful, and yeah, I'll see you guys next week. Good luck on the series work. I'll probably upload my video on Thursday or Friday. Yeah, see you guys soon.